Hi, everyone. We're so excited to have everyone be here. We're going to go ahead and transfer over to our first panel, which is going to cover the legal and technical insights that are powering data centers. So I would welcome our first round of panelists to come on up. So a big focus and sort of our intention with putting this panel together was trying to sort of mix in the technical considerations that Professor Ortega just talked about, as well as some of the policy implications of that, wrapped into what that looks like in legal practice and what we might see every day. So we wanted to kind of keep our questions very broad. First, I would love to go and have each of our panelists introduce themselves and give just like a quick background of what they do, and then we can get started into a few questions and start the discussion. Are they started?
I think they're off. If you just
flip it up. Yeah.
Should we use them?
Yeah.
I'm Al Ortega. I didn't say much about what I do. I'm a professor of mechanical engineering. I'm the director of a National Science Foundation center called the Center for Energy Smart Electronic Systems. It's an industry, university, cooperative research center. So we work with many, many American companies, primarily American companies, and primarily on data center technology. Myself, I'm a cooling specialist. We work on advanced cooling systems, and in our center recently, over the last 5 years, it's blown up. We've been around for 15 years. We've had ups and downs, and we've had times where we couldn't get much interest. But lately, we're the hottest ticket in town, right? All of a sudden, we're much in demand. So it's been a crazy time to see a technology that essentially that's just blown up, and it's got lots of issues and problems. So I have the unique perspective of getting to work, for example, directly with NVIDIA on some of the big problems that they're creating, and it gives us a great opportunity to be able to work on real cutting-edge kinds of issues.
Good morning, everyone. I'm Phyllis Kessler. I'm of counsel at a law firm in New Jersey, Greenbaum, Rowe, Smith, and Davis. I'm an energy attorney, admitted in New York and New Jersey, but I worked at Duane Morris before this firm and worked on projects both throughout the country and also some international projects. I've been in practice for a number of decades at this point, so I worked through initially regulatory energy practice for a long time, and worked all the way through deregulation and the onset of independent system operators and RTOs, and subsequently began doing energy-related transactional work. So I've worked on a lot of projects, and among those projects, I've had a couple of data center clients, and one of them in particular, we looked at bringing power to the data center. So there's a lot of complication and things that I'll be able to talk about in response to some of the questions.
Hey everyone, thanks so much for having me. I'm Shelley Welton. I teach at Carey Law. I teach energy law and climate change law and environmental law. And most of my research is on sort of big questions around how institutional design relate to outcomes in the energy space. So I've done a lot of work looking at regional grid organizations, how they're set up, and how that relates to sort of what you get out of them in terms of decisions about how to structure electricity markets, transmission planning, et cetera. And then I've also done a good bit of work at the state level, looking at state public utilities commissions. I'm particularly interested in questions of climate change and energy affordability. And I would say it's not so much that I work on data centers as I feel like data centers have worked on me. Like, you just can't be thinking about the set of issues that I've been thinking about and not have data centers loom front and center right now. It is just absolutely driving the conversations on both energy affordability and climate impacts, which I'm sure we're about to get into.
Thank you guys so much. So Al mentioned sort of a lot of the energy intensiveness and the scale of what we're looking at. And something that I've been wondering when I was putting this panel together was, so we have these existing legal and regulatory frameworks that may not necessarily be able to adapt or, might restrain what can be done with data centers now. So I was wondering if you could each speak from your perspective on how, the existing legal and regulatory frameworks might shape what's actually possible, what's going on right now in terms of transmission or building or anything along those lines. And feel free to hop in wherever. I kind of want to keep it casual and just make it a discussion. You want to start?
I could start. Well, I've seen a lot of transition over my career, so I will say that sometimes it happens in fits and starts, but on the other hand, there is a lot of adaptability. And I'll just as an aside, I'll say that when I started my career, I don't think I ever thought that there would be such a thing as multiple providers of electricity, or for that matter, multiple providers of telecommunications. So there's been a huge amount of adaptation. But that being said, with the current structure, there are a lot of issues. And I'm not even sure where to start. I'll say that one of the places that, with a large data center, and large data centers are normally going to have to go through the queue at an independent system operator or RTO. And those queues can often be very long. A lot of the projects that are in the queue may or may not get built, but there's the constraint, I think, to the largest extent is the staffing at the ISO or RTO level. Like, how quickly can the staff review an application? Look at the engineering, so I'm going to look to Al, but that's one big issue that comes up with the data center project if it's a large enough project. And I don't remember who said that there have been many data projects in our midst for a long time, and there's data center growth would happen with or without AI, I believe, but AI is just putting on the additional pressure. And so that's one thing on the energy level. Another thing at the energy level is how does the utility that's going to have to build the lines that go to the data centers to carry the power, what's their supply chain like? What's their internal engineering like? How much can they get done and how quickly can they get it done? And with the level of uncertainty, and also I think I don't know how much people here know that utilities they have a long history of running their businesses, and they've become more nimble since deregulation, but there's still a utility mindset that often takes a long time to get a project through the utility process. So there's got to be, advanced planning is going to take a long time. So again, that's another issue. There are many other issues, but I would say that another big issue is where's the power going to come from? And that is because the actual source of the electrons is not the utility for the most part. Where we have deregulation, the utilities have spun off their generation. So that means that the electricity has to come from some third party if it's not going to be self-generated. And what I've been hearing is, and I'm sure most people here have heard this, is that the large players are looking at nuclear. So, okay, I'm going to contract for a piece of the generation out of a nuclear plant. Does that plant exist? And if it doesn't, how long is it going to take to build? I mean, what we saw in the past is we were talking more than a decade in most cases. So is the power source going to be available? And if it's not, are you going to build it yourself or have a third party build it for you? In which case there are a lot of, among other things, there are a lot of contract issues, as well as the supply chain issues. But from the legal perspective, you're going to have to negotiate with, well, either way, whether you build it yourself, you're going to have to negotiate with your contractor to build it, and there's a lot, many, many issues surrounding that, not the least of which include the environmental issues. And if not, you're going to enter into a contract with someone to supply the electricity to you, most likely on your site. So, and with on-site generation, there are also a lot of issues that come up in the local commission that regulate what you can do and what you can't do with on-site generation. And will it be considered on-site generation depending on where you site it? Are you going to site it on the same land that the data center is on? Or are you going to site it adjacent to that particular site? So again, there are many, many issues, but there are other panelists, so I want to give them an opportunity.
I think Phyllis did a great job sort of whirlwind touring us through some of the issues. Maybe I'll just step back and say a little bit about how I think about how this fits into sort of the broader public utility law space, right? So it's not like these are the first large loads that have ever had to go through the process of getting put on the system. And the traditional way that this would work is, let's say you have a big new manufacturing plant. It wants to locate in a community. It goes to its local utility and the commission in the state and says, we're planning to build, and the utility says, great, we'll fold you into our plans going forward. Sometimes if you have to extend some lines to the facility, and let's say, they do a study and they're like, actually, you're gonna kind of mess up the local transmission grid, the company itself might pay for some of those upgrades. But in general, whatever load is coming on the system, the utility just kind of takes responsibility for it and puts it into its forward planning, right? So it plans its distribution and its transmission and its generation, if it still owns generation, around the idea that it's just going to be adding load. And what I would say you see happening with data centers is this is just fundamentally breaking down because nobody can add any of those things fast enough to accommodate the number of demands of data centers coming onto the system, right? So just sort of the classic way that we know how to integrate load under public utility law is not working. And in part, I think that's just all the constraints on generation. We can't build it fast enough. We can't get it through interconnection queues fast enough. We can't get it permitted fast enough. In part, I think it's that our system of transmission planning, which happens at a regional level, has historically not done a great job of building the kind of big lines that we need to accommodate this kind of power growth, and is not rising to the occasion at this moment either. And so I think fundamentally, I think the regulatory barrier is that we constructed a legal world in which we had, slowly accreted load growth and the system could handle it. And that's just not the world we live in right now or going forward probably for decades. And so I think you just see a lot of tensions across sort of the schemes that we had that presumed that we would just be able to accommodate whoever came to the grid and asked to be served. And now you see utilities and regional grid operators basically being like, we can't promise what we used to promise, which was that if you came and asked for power, we would hook you up to the system. Like, we just can't do it anymore. And so we're going to have to figure out a new way to accommodate these new loads.
So thank you all for sharing that. I know you both touched on this a little bit about some of the limitations about powering these data systems, especially as the demand is increasing at such an exponential rate the past decade or so. I was wondering if you could expand a bit about those limitations on the energy efficiency, and specifically if cooling is driving the overall energy use and how that kind of plays into the power grid of it all.
I can say a few words about that topic. So energy efficiency, what drives the power consumption at its heart is the efficiency of the computing that's being done, right? So right now we are in a technology arms race, so to speak, because we're stuck with a technology that is being used. There is no other technology that's capable of doing the kinds of computations that are needed to do AI inferencing better than a GPU, for example. And of course, this is why Intel has fallen, on bad times, and AMD and NVIDIA and others have fallen on good times because, they happen to be ahead on a particular kind of technology. But the only way that you're going to, and so let's talk about why it's so energy dense. It's because of speed. Everything is about speed and what's called latency. Latency is the amount of lag time you have between getting a signal from A to B, right? So this is why data centers, for example, are really large and everything is all in one place, because you're literally trying to get things as close as possible to each other. You're trying to get integrated circuits as close as possible to each other, so you have these extremely dense chips. You're trying to get many, many servers packed in as close as possible to a rack so that there's very little distance between them. You're literally limited only by the speed of light. That's what I've heard many times in recent panels, is the speed of light is our only limitation. So we're trying to get things as close and tightly packed as possible. So there are really no breakthroughs on energy density on the computing side. The gains to be made are the software. How do we do computations? How do we do energy-aware computations so that we do not consume power at a constant rate, right? And I think there's a lot of strides that will be made in there. I wanted to use an analogy that I think will probably happen in this industry. When Intel was faced with the same dilemma, when their CPUs were power hungry and going up a power curve that they could clearly see was going to cause massive problems for everything from laptops to cell phones and all other kinds of consumer devices, they could see they were going to be in big trouble. Of course, we thermal engineers, we were licking our chops, right? Because that's a real challenge to keep those things cool. But that wasn't the answer. The answer is take that chip and break it up into 4 chips. Reduce the energy density on a single chip, right? That was number one. They made these multi-chip processors. So they redesigned their architecture. Secondly, they learned that they have to use smart software that will, for example, the term is throttling. It'll throttle the chip so it doesn't run continuously. It only runs when needed, right? So by the combination of re-engineering the architecture and re-engineering the software, they were able to get huge, huge gains in energy efficiency. And that, no doubt, is what's going to happen in this industry. Right now, we're barely seeing the beginnings of the engineering technology that's needed to do this, but it's not going to remain on this curve. This is why I think what I see right now, everybody being alarmed, but the technology is going to change. It will not remain on this curve. There's going to be other players. NVIDIA, right, own that stock now because they will not be the only company playing this game forever, right? On the cooling side, there's big gains to be made on the cooling side. So we only recently, for very large, power-hungry data centers, have started to use water to cool the data centers. Traditionally, like the big data center I mentioned earlier in Newtown Square, that's all air-cooled, big fans. They just blow air through the building. Right? We've been doing that for decades. But only recently, over the last 5 years, is it necessary to start pumping water through these servers in order to be able to absorb the heat at a more efficient rate and then carry that out to the cooling tower and so forth. Again, we just started to engineer those systems. There's big, big gains to be made. So here's an example of one thing that right now is much in debate, and that is the use of chillers. All right. So here's the basic thought. The basic thought is you have to circulate water into your data center rack to pick up the heat, take it out to the cooling tower. Okay, so the question that we're asking is, at what temperature does the water need to come in order to be able to keep the chip at 85 degrees Celsius, what's called its thermal design point? At what temperature should we allow the water to come in? Can we allow the water to come in? So traditionally, we've always thought we need cold water. We need 18 or 17 degrees C chill water in order to cool the device. But what we're learning is we can get much, much higher temperatures at the inlet and still keep the chip at a comfortable temperature, right? Now, this is bad news for chiller manufacturers. Companies like Trane and Carrier and other companies that you might be familiar with, because they're the companies that develop these devices, air conditioners essentially, but now they're liquid conditioners that produce chilled water. And the reason that this is a big energy gain is because to get chilled water, you need to use compressors. The compressors elevate the pressure of the refrigerant, and that's how we get cooling. That's how your refrigerator works, right? But these are massive compressors. So if we can eliminate the chiller from the equation, it's a huge, huge energy gain. So I think this is a really good example of how we might be able to reduce the cooling load from 40% of the total power to 30% or 20%. And that's a massive, given the numbers we're talking about, that's a massive amount of energy. So there are going to be lots of innovations that are going to take place. We're not going to remain on this slope. We can't remain on this slope, right?
We'll take questions at the end if that's okay. Yeah. So switching gears a little bit, a lot of, at least at the state level, we have like clean energy demands and emissions targets. So how are those types of considerations influencing data center like construction, and is that like limiting anything or causing issues? If anyone could speak more on that.
Yeah, I could speak to it, and also it's somewhat related, I think, to the energy efficiency issue. I don't know about Pennsylvania. I do know about New York, and I think this is very much a state-by-state question, but and in New Jersey as well. There are many states in which there are requirements to move toward, away from dirty energy and towards clean energy. And frequently it's by statute. It's also dealt with within the energy commissions, the utility commissions to a large extent. And those are at the state level. And the reason why I'm bringing this up is because, at least in New York State, there's a governmental, it's an authority, not an agency, which is called NYSERDA, New York State Electric. I'm forgetting.
Research and Development.
Thank you. Research and Development Authority. And they make grants for certain types of new generation or new technology. It doesn't have to be generation. But for fuel cells, they used to give money for fuel cells, but because fuel cells use natural gas to run on, that money disappeared. So When you talk about being able to be energy efficient, in my mind, for cooling, you might want to consider using fuel cells if you're building your own, you'd have to use them on a very large scale, but there are fuel cell technologies where you can actually stack the different fuel cells, just like you can do, racking and stack the computer equipment. You can stack the fuel cells and bring in a large amount of power. The reason why fuel cells are efficient is what is the byproduct of a fuel cell after the natural gas is used? It's water. So from an efficiency basis for a data center, you might be able to use the water from the fuel cell in order to meet some of your water needs. And I don't know, I think all of these things are in flux. Again, similarly, and at a larger scale, fuel cells are really basically mini CHP. So if you're building your own electricity on site, right now the only way that you can get electricity would be to build a combined heat and power plant. And then again, what is that? What it does is it creates both electricity and steam. Steam could run your compressors. However, again, at the state level, are you going to have an issue because it's not clean enough because it's using natural gas? So, and I think what you're seeing is things are kind of the policies are butting heads at this point, and what's going to become more important, where the states give, if they give, or are we going to come up with some technology that's cleaner? Certainly, wind is cleaner, but again, where are you located? Is there enough wind? In New York State, upstate, there are wind projects so that you can get clean energy, but then you have the question of how do you get the power to the site? So.
Yeah, I'll just add a couple words, right? Like, I guess I'll start by saying I'm really worried about this issue, right? Like, if you look, there was a recent report that gas generation doubled its rate of being added to the grid in 2025, largely due to data centers, right? And so I think just like fundamentally, if you care about climate change, data centers are putting real pressure on the direction that we were headed, which was towards an interconnection queue that was 98% clean energy a year earlier. Now, there's a lot of other forces swirling out there that are changing that energy mix, right? It's not just data centers, but I think the fact that they're demanding so much power so quickly and that they want it to be constant is really putting some real pressure towards gas, I think, as Phyllis is suggesting. So, states have control over their generation mix. That's sort of like fundamental jurisdictional divide of energy law. And so they have a lot of say here, right? And so I think, with your states that have the most aggressive targets, if your data center is connecting through the utility, then whatever clean energy targets apply to the utility are going to funnel through to data center power, right? So when data centers are connecting in New Jersey and they have a strict standard, if they're getting utility power, it's going to be as clean as New Jersey requires. I think the real open question comes with some of these proposals around ideas to let data centers, basically the phrase that people are using is bring your own generation, right? BYOG. And there's real open questions around if you tell a data center, we'll connect you to the grid more quickly if you BYOG, what does that power have to look like? A lot of the state clean energy standards are written specifically to apply to utilities because that was the game in town pre-data centers. But if you have a huge amount of power self-supplying through BYOG, it's up to the state to decide, does BYOG have to be as clean as the state power that we require of utilities, or might we carve out some sort of exemption for it? I just learned a new acronym earlier this week. So Illinois is proposing Beyonce, which is bring your own new clean energy, right? So So if you put in place a Beyonce instead of just a BYOG, then you've got data centers that are actually having to keep up with, climate goals in addition to just getting on the grid really quickly goals. Can I say one other thing really quickly, which is that I think a piece we haven't talked about yet, and I'm sure Al might have thoughts about this too, is there are a lot of studies coming out that suggest that if data centers would be just a little bit flexible in their load, which is to say if, if they would allow the grid operator to turn them off 0.1% of the hours per year, maybe 0.5% of the hours per year, maybe 1% of the hours per year, we could bring them online really fast, right? Because really what we're constrained by is, the hottest day and the most peak power demand. And so if you could turn some data centers off just for some portion of those hours, we could say yes to a lot more data centers entering the grid. A few data centers are getting interested in this idea and saying they might be willing to work with regulators. By and large, the message has been, we have zero flexibility. We couldn't possibly ever have our power interrupted. How dare you suggest it? But I think we're starting to come to a place where everyone's realizing that if we could build in a little flexibility, we could get around a lot of the challenges of interconnection.
I just wanted to say one other thing, which is with respect to Beyonce, bringing your own clean energy. Well, I think there's two issues. One is what I'm going to call the elephant in the room, which is that, under the One Big Beautiful Bill, the Trump administration eliminated tax credits both for solar and for wind projects, so that financing is a large issue, and it's especially with the third party, it's going to be more difficult to get investors in these types of projects, and they would have to be pretty much utility scale projects in order to have enough power to power a data center. So I think that is probably a very, very large issue here.
I just add a couple of comments. One, let me give you names of a few of these companies in case you'd like to write them down, maybe invest in them, right? So Bloom Energy has been around for a long time. Bloom makes these very large fuel cells that are being considered possibly for data centers. They're very portable. They run extremely hot. That's their biggest problem, right? There's questions about their reliability. But here's the interesting one. There are there are technology companies like GE that build gas turbines, right? And you know that they build gas turbines for aircraft. They're one of the 3 large manufacturers of the gas turbines for commercial aircraft, very large commercial aircraft, along with Rolls-Royce and Pratt & Whitney, right? There's also smaller companies that build gas turbine engines. Here's an interesting one, solar turbines, right? You know what they build gas turbines for? Offshore oil platforms, power generation in offshore oil platforms. Well, guess what? I saw a solar turbine booth at a data center conference recently, right? So I think right now, because there just is not enough grid power, it is inevitable that there's going to be on-site power generation. There's certainly going to be a lot of requests for on-site power. And there really aren't very many choices. Really, the choices are either fuel cells, which burn natural gas, or turbines, which also burn, fuel, natural gas, or other kinds of fuels. There just aren't very many alternatives. These are the ways in which you can generate on-site power. Diesel generators, which are common in the backyard of all data centers. All data centers currently have diesel generators in their backyard, but they're only used for emergency backup power. Whenever there's a blackout or grid blackout, the noisy diesel generators kick on, and they generate power to tide over until grid comes back on, right? So a couple of just observations here. If you look at some of the maps that are becoming increasingly available, the data centers are essentially following the grid hubs, right? If you look at all the proposed construction They're just following the U.S. national grid in the places where they're being able to tie in. This is a real problem because, of course, that's where communities and cities are, right? That's why the grid looks like that, because they're for where we live, right, and where we work and so forth. So now we're getting these competing data centers being built near communities. It really is highly problematic because then communities are now being affected by the potential of having data centers in their backyard, right? And of course, nobody wants a data center in their backyard. But here's a thought. Europe, being much, much denser than the US, has regulations now that data centers, before they're approved, they must demonstrate a certain amount of energy reuse, waste heat reuse. One of the things I neglected to say earlier is almost 100% of the electrical power that goes into a data center eventually becomes heat, eventually just gets dissipated as heat. That's an amazing thing that's always makes my head blow up. I said 100% of the electrical power, the gigawatt you're putting into a data center, will eventually show up as heat. That's amazing. So we should be able to capture some of that heat and be able to do something useful with it. And in Europe, there are a lot more projects now that are tying in, as you said, the combined heat and power. They're combining the data center power generation and the data center waste heat in district heating systems, for example, to provide hot water and space heating for buildings and communities. The problem in the U.S., that would require regulations, and you know U.S. regulatory control is much more difficult than it is in Europe. That's why Europe is so much farther ahead of us in demanding and mandating these sorts of things, right? But we could do something about it. If we're going to build data centers near communities, then we should mandate that they have certain very strict criteria of meeting energy efficiencies and helping their communities meet their energy needs, right? For example, by reducing their heating loads during the winter, right? I believe this is something that really should be taken seriously.
Yeah, go ahead.
Yeah, no. The one thing that that I should mention is that there are fuel cells that run on hydrogen. They're mostly in Europe. But again, they would require a lot of development. We don't have that much sourcing of hydrogen that can be available. I mean, there's talking about mixing hydrogen into the natural gas system, which would not make it totally clean. But you know, also, a lot of the clean hydrogen was being developed as a byproduct of wind. So interesting, but another issue related to this.
So I think we have time for one more question before we open up the floor and do a little Q&A for about 10 minutes. So looking ahead, what emerging issues do you think that policymakers or regulators should really be paying closer attention to? I know we've touched on this a little bit, but you know, as these energy-intensive developments are continuing, like where should we be focusing like attention and resources, do you think?
Well, I might kind of take this question as a chance to talk about what I think we haven't talked about enough yet, which is the cost issue, right? I don't think this is brand new, like everybody now understands that it's happening, but I think it's a huge part of the energy regulatory conversation is like, how do you handle the costs that this is putting onto the grid and by extension, ratepayers, right? And basically, I think this is again, like old system hits new challenge, but traditionally, regulators have, you know, taken all the costs, added them together, and basically just like allocated part to industrial uses, part to residential uses, part to commercial uses. And what you're seeing with data centers is that because they're coming on with such rapidity, they're really putting pressure on the traditional way that we've allocated costs, right? And so you're seeing estimates that maybe around 40, 50% of data center costs are not being absorbed by the data centers, but are being passed on to residential consumers, which is putting enormous pressure on electricity bills, which is why, you see things like, I couldn't believe this happened, but a couple weeks ago, President Trump got all 13 governors in PJM, our regional grid operator, to come to the White House and basically sign a statement telling the grid operator that it was all broken, the cost was a huge issue, and they needed to go back to the drawing board and figure out how they were going to manage rising costs. This is particularly a challenge in regions where we have electricity markets, including here in PJM, where basically the most expensive resource sets the price that every resource gets paid in these markets. And what that means is that when you have data centers escalating demand up, prices up, sort of like Econ 101, right? Everybody gets paid that price. It means that if that's the system you have, there's kind of no way to protect residential consumers from the demand that data centers are adding to the grid, right? So I think some of this is fixable by state regulators going back into how they do cost allocation and basically saying can we fix the rules so that data centers pay for the costs that they're causing, right? This is sort of Electricity Law 101 is cost causation. You should pay for the costs you're causing. And I think there's some ways to fix this so that data centers are. I think that the markets are a trickier proposition, right? I think it's going to take some real market redesign to think about how do we make sure that enormous quantities of new demand added don't spike prices for consumers across the board in ways where old generators are essentially getting windfall profits that they were never planning for in this system.
Yeah, I think just to make things really clear, because I don't think at least I know I didn't state this totally clearly. What happens is at the utility level, so this is at the state level, most of the costs, the new costs are coming in the wires because the utilities aren't responsible for the generation. They are responsible for getting the power to the site. And that could be at the transmission level, which is the highest level. It could be at the sub-transmission level or at the distribution level. Those are the costs that are going into the utility costs. And we could possibly have a separate utility rate class for data centers and make sure that all of the costs related to data centers land on the data centers. There's also a regulatory scheme, I guess. I'm not exactly sure how to say it, but one of the things within regulation now is that if you as a customer are required to pay a certain amount to get the lines built to your site, if new customers come onto the system on those same wires subsequently, they are often required to also pay for that plant, and it may ultimately reduce your cost. So I'm not sure how that would be dealt with if we had a separate data center classification for rates, but it's, it might possibly mean changing the way regulation works at the local level today. But separately, in terms of the power and the electrons that go on the system, that does get determined at the independent system operator level that is running the markets. So that's separate, and I think it's just important for people to understand that that what the ISOs do versus what the state utilities do. The ISOs are the regional providers, and they do two things. One is setting the power market, and secondly, determining what at the transmission level, if there's an interstate impact, what what transmission gets built.
Yeah.
So from a technology and engineering perspective, but thank you for your comments. I learned so much about things I know nothing about. But from the point of but I think an awful lot about it. In the design of data centers, we've come up with metrics that are related to how efficient are they, how efficient are they using resources. The two most important are something called the PUE. It's called the power utilization effectiveness. How effectively are we using the electrical power that comes into the data center, the PUE, okay? The other one, which my colleague Aaron Wemhoff will be able to talk about, is the water utilization effectiveness, the WUE. There are many, many others, but those two are very important metrics to be able to kind of give you a gauge about how healthy that data center is, how well it's using resources. In my view, these kinds of ideas, these kinds of metrics should be embedded in regulatory principles. If you're going to allow a data center to be built, we should mandate that they must meet certain PUE and WUE requirements. If we were in Europe, it's probably already been done. But in the U.S., the U.S. just, hates regulatory principles, right? Because we're a capitalistic country, first and foremost, right? But if we would demand it, then we would be able to deliver data centers that use power more effectively and use water more effectively. There's a lot of discussion. Let's be clear. If you reduce the power going to the data center, you're also reducing the cost to the data center operator, the data center bill. You're reducing its costs, right? So obviously, it's in the interest of the data center operator owner to have high PUE and high WE. The data center industry knows it's got a public relations nightmare on its hands, right? They started talking about this 2 or 3 years ago. They could see this coming. It's really a real thing, and it's now standing in the way of them being able to deploy data centers. But in my view, if you use some of these performance metrics, it would help essentially to force the data center operators to meet requirements where at least they're making inroads. There's another mega trend that I want you to be aware of that is rather interesting. The data centers we're talking about, you're probably thinking they're all being built by Google and by Amazon and Meta and all that. But that only is a part of the builders. There's been a huge growth in what are called colos, co-located data centers. Co-located data centers are companies that you've never heard of probably, right? I'll give you the names of a couple of the really big ones. Equinix and Digital Realty. What are those? Have you ever heard of those companies? They're huge, huge. They're among the biggest data center companies in the world. You know what they do? They basically build data centers so that you can put your equipment in their building, and they will provide power and cooling to your equipment. Those are called colos. The colos have been the fastest growing part of the entire data center industry. The reason I mention this is because to me, and again, I'm not an expert, I'll try to stick with what I know, but as an observer, I can clearly see that there's a difference between the incentives to a company like the Amazons or the Googles that own and operate the data center, as opposed to a colo that basically is building a data center. It used to be called a cash grab or a land grab, by the way, who are building data centers, developing the data centers, and then basically renting space in the data centers to hospitals and universities. Villanova uses a colo, by the way. We perform our administrative computing functions in a colo in Reading, Pennsylvania, as an example. But now we're looking at huge campuses of colos that are now become a very big part of the equation. And again, it's not so much about the engineering of it, it's about the thinking about ownership and responsibility and, sort of obeyance of regulations and those sorts of things. It makes me wonder, but I'm no expert, but I throw it out there for you all that are experts.
At this time, we're going to open up the floor for a quick Q&A before our first break. So if you have a question, raise your hand and I will bring you the microphone.
I don't know if I need the mic. I feel like I'm loud enough. So I have a
engineer. So with these system design, so I work in manufacturing for a heater manufacturer. So a lot of our clients are designing data centers constantly. They've been talking about new technology that involves water not cooling the servers, but rather a different liquid state that is much more energy efficient. And also they were talking about the sizing of servers and how they're able to be so much smaller than they were before with the advancement of technology. So they're able to get more servers in one place. I guess, what have you been seeing on the trends for using a different fluid for cooling other than water?
That's what we do in our research lab. So what you're talking about is using refrigerants for cooling and letting them boil, change phase from liquid to vapor when they pick up the heat from the data center. So I should have shown you some pictures, but this kind of technology is called direct-to-chip. And I showed you the picture of the Blackwell chip. If you can kind of a picture in your mind that you put on top of it, this copper plate, it's called a cold plate, and you flow the liquid through that cold plate, it absorbs the heat, which is being dissipated by the GPU. And then you connect all of these cold plates together, right? So currently, the big wrap-up is deployment of water-cooled cold plates. But what you're alluding to are two-phase cold plates. They are definitely going to be more efficient. The pumping costs are going to be much lower. And it is probably the future and this is why we're working on it, right? This is why we've been asked to look at it, because it's 5 years out or more, right? There is some question right now about whether we should deploy them now. I think already it's too late. I think there's just already too much ramp up of water cooling to where two-phase cooling will probably be a niche area for now. But I think that it will eventually be the next way in which we cool data centers. And some of you may have also seen pictures of what are called immersion cooling, where you take the server and you put it directly into the liquid, right? This is the way Bitcoin miners run data centers, primarily using immersion cooling. It's an amazing thing and rather scary to walk into a Bitcoin mine, because I cannot see a future data center where the room is full of gigantic bathtubs, full of liquid with the electronics immersed in the liquid. It's like something out of the Matrix, right? But seriously, I cannot see a future, and I'm not an apologist for the other type of technology. It's just that it's hard to imagine the future with so many technical risks. Just a quick comment about refrigerants. Refrigerants come with their own environmental risks, right? Right now, there's a big push to try to develop new refrigerants that have lower global warming potential, for example. So that's one of the things going on in the Honeywells of the world, right, that produce these chemicals. So that's definitely one of the directions it's going. You see, this is an example of why, like a technologist like myself, is not overly worried, because I know there's already a lot of thought about how are we going to bend the curve, right? We can't stay on this curve. We all know it. How are we going to bend this curve? And where can we attack this curve? And every engineer working in this area probably is working on something like that already, right?
Yeah. And I guess too, I just have a question regarding fuel source, because obviously the DOE has been regulating gas to make it that certain heat sources, specifically the boiler world and the water heater world, now to be over 95 or greater % thermal efficiency. So a lot of building owners are going to have to switch to alternative energies, which is great from a clean energy perspective. They're switching towards gas, they're switching towards electric, they're switching towards heat pump. But that's adding more pressure on the grid. So what have you been seeing for grid expansion to make sure that cities and towns are able to handle the increased grid pressure that's been coming on from the development of data centers, as well as the new designs that are being required to meet the threshold of the Department of Energy?
That's a question for one of the other panelists. Thoughts?
I mean, I think all the pressures that you've heard us talk about it's like a compounded set of challenges, right? So I think data centers are sort of the latest grid stress. They're not the only grid stress, right? So already we were seeing electrification start to put pressure on the grid. And data centers have basically just like ramped that up tenfold. And I guess maybe one other point that I'll make just to sort of tie these two things together is, when you look at sort of experts' projections of the best way to decarbonize the economy, the slogan that often gets used is electrify everything, right? Like you basically want to push every use into electricity that you can. So that's everybody driving an EV, that's industrial uses going electric as much as they possibly can, that's heating going electric. When you have data centers that are putting this kind of upward cost pressure on the grid and sort of like straining the ability to build resources, electrification gets really threatened, right? So like not only is the grid struggling to deal with data centers, but I think we're probably setting electrification back a good bit the longer we don't deal with the cost issues, because you're not going to switch to putting everything in your home on electricity if the bill is going to go up rather than down.
We have time for one more question if anyone else.
Hey, this is Joe Harmer. I was here on the Environmental Law Journal and graduated recently, so glad to be back. And thank you for this great presentation, great panel. So I work at the Pennsylvania Office of Consumer Advocate with my boss Mel here, and we are thinking a lot about these things. And one thing that we're thinking about is load forecasting, meaning there's this overall energy system, and it has to be planned. And it has to be planned based on certain assumptions about, what's going to come online and when. And, some actors have incentives to send out a lot of requests because, then you have to build more things for them. And then they also get multiple opportunities to sort of say, well, maybe we want to build here, or maybe we want to build there. And so I'm curious, in determining long-term load projections, are these engineering changes going to affect that potentially? And also, how could that process be made more effective so that it doesn't, overestimate, but it also doesn't underestimate the amount of load that's going to connect?
This is a tough one. I mean, I think this is a perennial challenge for the electricity industry. Like we did overly aggressive load forecasting in the 70s and had to eat it. Now we're coming back around and seeing the same challenge again. Just a couple thoughts. One is, I think this is a great place for regional coordination, right? Like it's clear that a lot of data center developers have an interest in being as secretive as they can for understandable reasons. There's like a race to find the best spots to put your data center, and you're going to put it in several places, and you're going to see what the costs end up looking like, and you're going to take the best offer. But I do think states have some ability to coordinate among each other to do some good work to sort of figure out, like, where are we seeing 5 requests in the region, and we know we should only be factoring one of those requests in. I think it's a tricky question exactly how much transparency you can require of the data centers and exactly how you can put that data together, but I think it's a great place for looking at collaboration. The other thing I'll say is I think this is one place where like incentive regulation can force data centers to reveal more of their information than they might otherwise want to, right? So I think a lot of the pushes that you're seeing, this is not specifically on load forecasting, but it's basically on allocation of risk of who eats it if the load is forecast wrong, right? So like Ohio put in place a new tariff where, I can't remember the exact number off the top of my head, the data center had to offtake something like 80 or 90% of the power they were saying they needed for 10 or 15 years, right? And so in that case, you're basically saying like, if you tell me you need this power, you're going to buy this power, and if you're wrong, the risk is on you and not on the consumers. So I think sort of movement in this direction in terms of rate design is maybe one way to get at the sort of deep challenges of forecasting.
I mean, I agree, and I also see this as just slightly different. Going back to the idea that possibly we have a separate class for data centers that I see that maybe what we want to do is, it's not so much the power that, that we're paying for, but we're paying for the capital improvement, and that, that should be borne by the data, to me, borne by the data center. You could do it one of two ways. You could actually require an upfront payment or payments over time, maybe in chunks, by the data center, or you could put it through in the rates, in the rate classification to the data center, so that the data center is the one bearing the cost of capital, but it goes through as cents per kilowatt hour of power that's put on those lines and consumed by the data center. I think in terms of making sure that the data center actually bears the cost, it's probably better to do it from a contract point of view, because if the data center doesn't end up using the amount of power that's actually projected because of efficiencies that either develop before the data center equipment comes on, or efficiencies that come over time, you may not actually be able to recoup the costs if you put it into, like either cents or dollars per kilowatt or per kilowatt hour.
All right, well, that's all the time we have. Let's give a round of applause for our wonderful panelists.